everyone. My name is Siti Farzana bint Hamza, metric number 225427. Today, I will be presenting the introduction of our project on oil recovery from palm oil mill sludge pit. Resource recovery is the process of extracting variable materials from industrial waste instead of disposing of it. This concept aligns closely with the circular economy, where waste is reused to reduce environmental impact and improve economic sustainability. In palm oil mills, sludge generated from mill effluent still contains unrecovered oil. If this oil is not recovered, it increases both BOD and COD levels, which can cause water pollution. At the same time, oil loss reduces the efficiency of palm oil extraction. Therefore, recovering oil from sludge pits is essential for both environmental protection and improved performance. From an environmental perspective, residual oil in sludge contribute to a high organic load, which is reflected in elevated BOD and COD levels. During anaerobic degradation in the sludge pit, methane gas is produced, which is a potent greenhouse gas. Recovering oils helps reduce pollution and limits greenhouse gas emission, supporting environmental sustainability. From an economic perspective, oil loss in the sludge may seem small, but the large scale of palm oil processing means the cumulative loss is significant. By recovering this oil, mills can improve overall yield and generate value-added products such as biofuels or compost, which enhance profitability. After crude palm oil extraction, wastewater containing water, solid and emulsified oil flows into the sludge pit. Fine oil droplets attach to solid particles and settle, forming sludge with residual oil. If this oil is not recovered, it causes economic losses and increases environmental treatment needs. Understanding this process shows why oil recovery is important both efficiency and sustainability.
Hi, my name is Medina binti Mustafa and I will continue the slide presentation with sludge pit characteristic and oil potential. The first one is physical characteristics. Where the first one is moisture content. It has a very high moisture level, and raw palm contains approximately 95 to 96% water, so sludge is highly wet and semi-liquid in nature. The second one is total solids, which is about 4 till 5%, and the suspended solid is around 2 till 4%. Number 4 is solid composition, which is mainly mesocut fiber fragments, cellulosic debris and fine particulate matter. And the last one is bulk properties after drying. Its significant solid and ash fraction reported ash content around 29.8% from pyrolysis feedstock studies, and the bulk density is in the range of hundreds of kilogram per meter cube. For the chemical characteristic, first is residual oil content approximately 0.6 to 0.7% due to incomplete oil separation during clarification. Oil is often emulsified or attached to fine solids. And the second one is organic load, which is very high BOD and chemical COD. Values commonly in the range of tens of thousands of milligrams per liter. And the third one is major organic compounds, which is high concentrations of soluble sugars, proteins, fatty acids and other degradation products from food processing. And the last one is mineral content, which contains significant levels of potassium, phosphorus, calcium and magnesium. For factors influencing oil content, first one is mill operational efficiency. Inefficient processing increase oil losses to palm, raising sludge oil content. And second one is settling time. Short hydraulic retention time in clarifiers prevent oil droplets from coalescing and keeping more oil trapped in sludge. And the third one is temperature. High temperature reduce oil viscosity and improve space separation. Cooler conditions increase oil entrapment in sludge. And the last one is low rate and feed loading. High flow velocities reduce separation inefficiency, causing more oil to carry over into sludge.
My name is Fajin my metric number is 2255X6. So now I'll go into proceed the process and technology. The process begins by the gathering raw sludge and passing it through a screening unit to remove debris and protect downstream equipment. The material is then conditioned in a heating tank to reduce the viscosity and break emulsions. This allowing for primary gravity separation in the oil separation tanks. Finally, the centrifugation is used to extract any remaining oil from high solid mixture to ensure the maximum yield before the final product is moved to recover oil storage for reuse or sell. To compare our two systems, the decanter centrifuge uses high-speed centrifugal force to efficiently separate oil, water, and heavy solid in a single compact step. Through it comes with higher energy and maintain the cost. In contrast, the dissolved air flotation (DAF) use air bubbles to float lighter suspended solid to the top, and offering a lower energy and lower maintenance alternative that require a larger physical footprint and chemical additive. Ultimately, the centrifuge is the heavy-duty choice for complex waste, while the DAF is a more cost-effective solution for lighter separation needs.
Hi, my name is Elizabeth Yimlin with matrix number 225748, and now I will be presenting the basic economic analysis. Before we dive into the details, let's first set the context. The purpose of this economic analysis is to evaluate the cost and revenue of recovering oil from palm oil mill sludge. We will focus on the key factors such as sludge handlings, oil recovery costs, and the overall economic feasibility of this process, and compare them with the potential revenue generated from the recovered oil. This will help us determine if it is financially worth investing in this process. Let's now look at assumption we use for our analysis. We assume that the mill treats 100,000 kg of sludge waste per month and that 3% of this waste can be recovered as oil. The sludge handling cost is 0.03 ringgit per kilogram, while the processing and utility costs are 1 ringgit and 20 cents per kilogram of oil recovered. Finally, the labor cost is 3,200 ringgit per month for one operator working on recovery activities. Let's move on to the calculations of oil recovered. We start by multiplying the total sludge treated, which is 100,000 kilograms, by the recoverable oil content, which is 3%. This gives us 300,000 kilograms of oil recovered each month. Now, let's look at the sludge handling cost. With 100,000 kilograms of sludge treated per month at a rate of 0.03 ringgit per kilogram, the monthly sludge handling cost comes to 3,000 ringgit. This cost covers transport, pumping, and basic handling of the sludge. Next, we consider the total money cost of the oil recovery process. The sludge handling cost is 3,000 ringgit, while the processing and utility costs amount to 3,600 ringgit. The labor cost is 3,200 ringgit, and therefore, the total money cost of oil recovery is 9,800 ringgit. To summarize, we recovered 3,000 kilograms of oil per month with a total money cost of 9,800 ringgit. Next, we will look at whether the revenue from selling this oil can offset the cost.
Let's show the financial performance of the oil recovery system, all of revenue and profit. From the sludge treatment process, about 2,000 kg of oil are successfully recovered each month. This recovered oil is sold at a market price of 3.50 ringgit per kilogram, which generates a total monthly revenue of 10,500 ringgit. On the cost side, the total operating cost is 1,800 per month, which includes sludge handling, processing, and utility costs as well as labor. After deducting all operating costs, the system produces a net profit of 700 ringgit per month.
Moving on to economic feasibility discussion, that the key finding from this analysis is that the oil recovery process is economically feasible as it generates a positive of a monthly profit for 700 ringgit. That confirm that the estimated revenue is sufficient to cover all operational costs. However, the feasibility of the system is highly sensitive to two main factors, which are the selling price of the recovered oil and the recovery efficiency, which is assumed to be 3%. Based on the total monthly cost of 9,800 ringgit, the break-even price is approximately 3 ringgit 27 cent per kilogram of oil. Despite the narrow profit margin, this project remains strategically valuable because it reduces organic load in the effluent system and supports circular economic practice by converting waste into a secondary income source.
Assalamualaikum and hello everyone. And now I'll be talking about the benefits of oil recovery, especially for the environment, operations, and sustainability. The main benefit of oil recovery is that it reduces oil loss and environmental pollution. Oil trapped in sludge pits is a wasted resource. With modern equipment such as three-phase centrifuges, about 90 to 95% of the oil can be recovered from the waste. This allows large amounts of oil to be reused, giving economic benefits.
At the same time, oil recovery helps prevent harmful substances like polycyclic aromatics, hydrocarbons, PAH, and heavy metals from leaking into the soil and groundwater. Removing the oil also can reduce hazardous waste by up to 80%, making the remaining waste more stable and less harmful. Oil recovery also improves sludge management and wastewater treatment. Raw oily sludge, especially palm oil mill effluent, is thick and difficult to track. It can cause blockage, damage equipment, and reduce the efficiency of treatment ponds. When oil is removed early using cyclones or high-speed separators, the remaining waste becomes easier to handle. This lowers the chemical oxygen demand (COD) of the wastewater, improves treatment efficiency, speeds up pond cleaning, and also extends the life of treatment facilities. Lastly, oil recovery supports the circular economy. Recovered sludge palm oil can be reused for non-food products such as biodiesel, soap, and animal feed. The remaining organic solids can be turned into biofertilizers or soil conditioners and returned to plantations. This approach reduces waste, saves resources, and supports long-term sustainability. I think that's all from me for the advantages of oil recovery.
In conclusion, this study shows that oil recovery from palm oil mixed sludge pits is a practical and beneficial waste management approach. Technically, the use of heating and separation methods such as decenter centrifuge and soft air flotation can effectively recover residue oil, that improving overall extraction efficiency and reducing oil entering the pumping treatment system. For economically, the recovered oil provides additional income that is able to cover operating and labor costs, resulting in a positive profit. For environmentally, oil recover reduce BOD and COD level that improve wastewater treatment efficiency and support circular economy practices through biodiesel production and sludge reuse. Several recommendations can be made to improve oil recovery efficiency. First, better control of upstream processes such as sterilization, digestion, and clarification is important to reduce oil losses before reaching the sludge pit. Second, suitable recovery technology should be selected based on sludge characteristic and operational scale with a proper maintenance and operator training. Third, integrating oil recovery with existing pommy treatment system is utilizing the remaining sludge for biogas or composting can be improved sustainability. Finally, future studies should explore advanced recovery methods such as membrane and enzyme assist technologies.